Okay. So 3.5 is what we're doing today. And so here's the question is, how do you solve these? There's no such thing as like, like we have a quadratic equation. We don't have anything for cubics or for quartics. So what we're going to have to start doing is analyzing these in different ways. Okay? So one way is to study extrema. Come on, don't break. Don't break. Extrema, there we go. Okay, extrema is basically a way of saying, mins and maxes. Well, there should be an E there, but whatever. So if we have, let's say, a cubic. Well, this isn't caca, this is AKA. AKA there. Maximizing the caca in the class. So this is exactly what you think it might be. This is a local max or min? Max. This is a local min. Can you guys guess what degree this polynomial is?
Third.
Fifth?
No. Fifth. Or third. Why made me say fifth? We just saw it right here, right? Cubic, 3. This was supposed to be smooth, but the computer crashed on me. How many extrema do we have? 2. Okay. And there's another thing that I'm going to introduce. It comes later in the chapter, but I'll just do it now. Turning points. Where do we turn around? So when do we go from I'm going up to I'm going down? I change points right here. This is a turning point, and this is a turning point. So I have 2 of them. Now let's look at the quartic. Quartic, it's not exactly a symmetric W, but more or less this is the shape. What's this point right here called? Local max. I'm going to keep the local out. Okay, I'm just going to write min and max. What's point is this?
Min.
And then, so this one is degree, what degree is this?
4.
How many extrema?
3.
How many turning points?
3.
Now you guys tell me, do you guys see a relationship between the degree and the number of extrema?
Yes.
So you guys tell me, what is it?
The degree is 1 higher from above.
Right. So let's write it another way. If we have a polynomial of degree n, then we have at most how many extrema? If the degree is n, n minus 1. And turning points. Now this is going to help us out to identify polynomials. For example, if I have this polynomial, what degree could this be? Seventh degree. Why? 1, 2, right? 6 turning points. So that's the importance of this, is we can use turning points and the extrema to infer what degree it might be. So that's good. Now we can identify any type of polynomial, right? It's a good first step. Okay. Now sometimes there's something funny going on that we have to figure out. So let's look at P of x is x cubed minus 2x squared plus x minus 2. And let's look at this graph on our graphing calculator. So what we want to do is we want to identify extrema. Now, just so that you guys know, x cubed, this is a cubic, right? But this graph looks like this. So it doesn't necessarily have to have local extrema. Okay, it has at most it could kind of wiggle a little bit, but it doesn't have to. So the question is, what happens with this one here? Because our graph is our friend, right? Graphing calculator. But you have to know what it's telling you. Sometimes it doesn't tell you everything. All right, so what we're going to graph here is y equals x cubed and whenever you start a new day, you go zoom 6. I don't know what I have in here from last time I used this calculator. Zoom 6 just says standard, right? Now, how many extrema do I have here? Do I have any?
One.
Do I have a min or a max?
Both.
Both? And what are the values? It's not exactly obvious, right? So what am I going to do? Now, one is I can change my window if I'm good. But another way I could do it is I could just go to zoom. Well, first of all, where's all the action happening here? Something is going on right here, right? Mm-hmm. It looks like it might go up a little bit, then might come down a little bit. So let's zoom. And then this one, we're just going to zoom in. So I'm going to go near it. Well, it goes too fast. So I'm going to kind of zoom in. Either goes too fast or too slow. I'm not even clicking anymore. There we go. I'm going to go down. So this way I don't have to set a window. I'm just going to say zoom in right here. Tell me what's going on right here. Now it's a little bit more obvious, right? Now it looks like there's a max right here and a min right here. So I want you guys to find what is this point and what is that point. What is the min and max of this problem? You guys tell me.
I got min 1.0 and
And what's the y point?
-2.
Okay. So the min is -1 or 1, -2, right? And what's the max? Maybe someone else did it, so
I don't know if I did.
we could share our work.
It looks like it's x. X is 1 and y is negative.
Now, do we want looks like or we want exact answers
1.0000012
for min or max?
for the x value. For the minimum.
Oh, we already got the minimum. We're done with that one. We want the max now. So we're going to use calc max, right? So you guys all started with the min? And no one started with the max?
So it's 1.4 and -1.7.
1.4? Are you sure? Because this is 1 right here. So it's got to be like,
It's like -1.7. 1.3. -1.5.
you guys get this?
I got 0.319 for the x value. And the y value is correct.
All right, I'm going to do it. Second calc, because we all should get the same exact answer. Make sure you're clearly to the left of it. If you're not all the way to the left of it, you're not gonna. It's not going to give you the answer. So make sure. Is this clearly left of it? Is this, and then make sure. Like if I were to stop right here, it's going to give me this answer. You know. So you have to make sure that it's clearly bounded in there. The max is clearly in between there somewhere. Press enter. There we are. Everyone should have the same exact answer. Maybe the last 2 digits here are different, but that's round off error. So that's turning points and mins and maxes.
Can you double check on the min, please?
It's double checked. It's right. So that one's an exact answer. So these are the 2 answers. You can even see right here, 1, -2. Okay. Now we got to talk about end behavior. We're going to talk about all kinds of stuff that we're all going to put together to analyze stuff pretty soon. What I'm going to do is basically give you a toolkit of a bunch of different types of problems. I'm going to say we're going to have turning points and mins and maxes and end behavior and some other stuff. And we're going to use it to break apart 9th degree polynomials. So I'm just going to kind of tell you the answer without having to explore it. So this is basically, we have the degree of a polynomial, and we have the sign of the leading coefficient. Actually, I'm going to let you guys tell me what this is. So here we have positive, negative, and the degree is either going to be even or odd. Now let's explore what this might mean. So let's do an even degree polynomial with a positive coefficient. So the easiest one is x squared. I'm going to go back to Zoom 6, right, because I messed it all up. Now notice what happens in the end. What happens as I go left, do I go up or down?
Up.
As I go right, do I go up or down?
Up.
Now let's see if it's true for another even one. So let's do x to the 4th. Does the same pattern hold?
Mm-hmm.
So I know that if it's an even and the sign, what we're going to write this is like this. That way and that way. As I go left, I go up. As I go right, I go up. Now let's do negative. What do you think? What's the negative sign in front going to do? It's going to flip it downward, right? So I'm not even going to graph it. I'm just going to use my skills from X reflections to flip it downward. Now odd. So what's the easiest odd function to use? Yeah, well, let's use x cubed. As I go left, I go down. As I go right, I go up. And it's true for the rest, so we'll just say it. So odd is when I go left, I go down. When I go right, I go up. And then if I flip this upside down, so we have all 4 possibilities here. And this is where I just started doing the YMCA. Is it like this, like that, like that? I walk like an Egyptian. You're going to have to know this. Use this. If you forget, well, how did we figure it out? We just graphed a simple thing. If I forgot what happens when it's negative and odd degree, I just graph one and I say, oh, left up, right down. Left up, right down. Okay. I'm actually going to put this on here. Let's do some problems here. Determine the end behavior. Now these questions should be no more than 30 seconds each. Because what are the 2 things you're looking for? Degree and the leading coefficient sign. So only 2 things you care about. So f of x. So I'll give you guys a few minutes to do these. And my g of x is wrong. This is a cubed. So f of x, is that an even degree or odd degree?
Even.
Even. So even tells us it's either both up or both down. What's the leading coefficient? The sign? So it's going to be both up. G of x. Leading coefficient is positive or negative? Positive. The degree is even or odd.
Odd.
So what's that? Left, down, right, up. Leading coefficient here is negative. The degree is even, so that's both down. What about k of x? Is it like this? Is it left, down, right, up? Why not? This is positive and this is degree 1. What's the leading coefficient here? This one right here. The degree is odd
Negative.
and this is negative. So that means. So you remember, if it's not in order, you have to look for the highest term there. All right. The x-intercepts are super important in this chapter. Now remember, if your function has a real zero, it's an x-intercept. If it doesn't have an x-intercept, it could have complex zeros, but they're not real, okay? So real is the key point here. So let's think about some easy functions. So this is a cubic, right? How many zeros does it have? 1 0. You know, I'm just going to keep using the same line. Now, what about this one?
2.
1, 2. What about this one?
3.
Is there a way I can get 4?
Yes.
How? Well, with only using a cubic, what I mean. With only using this shape, is there a way to get 4? No. So what that means is the number of x-intercepts, which also means real zeros, for a polynomial of degree n, is at most n. So a third degree polynomial can have 3 zeros. But it doesn't have to. It can have 1 0. It can have 2 zeros. It can have no zeros. Well, can it have no zeros? Because of the n behavior, since I'm going to negative infinity to infinity, there's no way to draw this line where I don't cross 0 at some point. All right, now let's start doing some more math. So P of x equals x cubed plus 5x squared plus 5x minus 2. Now the name of the game is to find the zeros. Find the x-intercepts. So this is a third degree polynomial, right? So does it have 1, 2, or 3? We don't know. You guys find them. What I would recommend is you guys can work in groups. I'll find this one, you find that one, you find, or however many there are. Then you don't have to do it all 3 times. So we don't know. So we're going to use the calc zeros to find all 3 zeros. Has anyone found the leftmost one?
I got 0.30.
Wait, what?
0.30.
Mm-hmm.
Oh. Yeah, I got that.
You found the rightmost one.
Yeah.
What's the middle one?
-2.
All right, you found all 3 of them. Now, this technique is very important. To find x-intercepts, which is the same as finding zeros, you can use your graphing calculator. And I'm going to show you some more tricks with your calculator using the next problem. Finding zeros is key to this chapter. How hard is it? Because it's really easy, right?
And the test be on all of them.
Well, what I'm saying is remember this when we get to the next sections. Remember to the next sections, when I say find the zeros, you guys just admitted that this was easy, right? So don't forget that. Well, it's pretty easy. Yeah, I guess easy is an opinion. It's easier than what's coming next, let's put it that way. But that's an opinion also, I guess. Now, toward the end of this chapter, we're going to be doing 9th degree polynomials. And they might take like 2 pages to solve. So, I don't know. Start out easy, work our way up. So we're going to do a few things. 1, domain. 2, range. 3, all extrema. And then all x-intercepts. Now there could be at most, well, let's just ask this question here. How many x-intercepts, what's the most I'm going to have to find? 5, but it might be 4, it might be 3, it might be 2, it might be 1, right? How about extrema? At most I'm going to have 4. So that's 4 things to find, that's 5 things to find, and so that's 11 things to find. This is also a good time to take a break. So we'll take a break, and then when you come back from your break, start working on this problem. Let's see, we're going to find the extrema of x to the 5th. This is a way that doesn't require the min and max way to do it. 2x to the 4th minus x
What was plus 2x? Oh no, never mind.
Okay. Zoom standard. Now, there might be something going on up here, so I'm going to zoom out just a little bit. I'm going to go to, okay, this is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I'm going to do maybe 5 to, well, I just want to scroll up a little bit. So let's do -5 to 5. And I want to go up a little bit more. So let's go to 20. Okay, so it looks like pretty much this is what's going to happen in the end. So here's one way to find the maximum here without having to zoom and everything. Let's get out of here. Now, it looks like it's about 2, right? For sure it's between -3 and -1. Would you agree? All right, so let's use those numbers. So let's get out of here. Now I gotta remember where this is at. Math. Oh, look right here. Math. Which one of these do you think will help me find the maximum?
7.
Of 7, right? So this is a way to do it really quick without having to click, 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 click. Now here's how it works. I got to put y1 here. So alpha f4 y1. Find the max of y of x between -3 and -1.
How did you get y1 alpha what?
Alpha f4.
Oh.
So it's saying let x go between -3 and -1 and find the max.
And what do you do after that? You just
Press
hit
enter. It's thinking, and it says the answer is negative 2 point. Is that what you guys got?
Yeah.
Now check this out. To find the min, I can just second entry. I'm just going to overwrite this max part. You could just go straight to F min. Math, F min. Notice that the Y1 and the X are still there. Now where was the min at? I already forgot. Somewhere, I don't know, somewhere between -1 and 2. Would you guys agree with it? It's because it's kind of flat here, so I don't know exactly where it's at. So I'm gonna put -1 to 2. Now you can still do the calc min and max if you want. This is secretly what it's doing. Remember when you choose the left bound and the right bound? That's all it's doing here. So 0.408. Now check this out. What if I wanted to find out what is the minimum value? Then I go to alpha. So this is the x value. Would you guys agree? What is the y value of this? So I go to alpha F4 y1. What is y of, and how do I get this answer in here? I press second minus sign. Second answer. What is the y value when I plug in this x value? You guys see that? What is f of this? Press enter. Got my 2 points. Without using the, trace, calc, and everything. You can choose which way you want to use. This is just another way to do it. If you prefer the calc, well, when you do the second calc, it actually gives you both values at one time, right? But this, well, you guys decide. You now have another method. And the zeros you guys could find, right? So
Would you get for the minimum?
this right here, 0.408, -4.24. What'd you get?
Not 0.21 for the min.
You didn't make your balance big enough. So I'll write down the answers. So the extremas are -2.02, comma 10.01 max, and the min was 0.41, -4.24. The x-intercepts, just so we can move on, are, how many x-intercepts do we have? 3 from the graph. Is -10, 1.140, and -2.520. Now remember, all of these are just found by tracing around the graph, right? To do this problem without a calculator is impossible. Well, it's not impossible, but we wouldn't be able to do it within an hour, right? So that's why your calculator is so important on the test. Make sure your batteries are charged up. Bring extra batteries if you need to. It's just weird.
So, to clarify, for the max, it would be just the -2.02?
No, yeah, I put the actual value.
Okay, and then the min would be the -4.2.
Yeah.
I mean the 0.4.
I'm gonna put a picture of this on here. Yeah. So now is what we're doing, is it doable so far? Okay, I'm just trying to. We're in good territory. We're in good, safe. So this is the max. This is the min. And then the zeros are right there. Okay? Question?
One last question for you. The one you just did with the alpha F4, is
Mhm.
there something I'm missing? Because when I do that, it literally just shows me a picture of the graph.
So if yours doesn't do that, you have to go to vars. Everyone can do this. There's just a shortcut if you have alpha. Vars, y vars, function, and then there's y1 right there. That should work for everyone. So you press vars, you press right to go to y vars, and then function.
And then what's going into that? Because when I do mine, it's like not.
Well, this will come out. Would you agree?
Yeah, no, I got that. But
So then you put whatever you want in there. You could put y of 1 if you wanted to. Whatever you want to calculate. You're basically calculating, when I plug in x, what is y? Yeah, negative.
Positive.
So you might have messed up when you might have messed up here somewhere. But
Yeah, I do.
question?
Yeah, can you walk me through the values that you put for the minimum and the maximum, like where you were right now?
These right here?
No, when we're trying to figure out the extrema.
Right. So why I chose -3 and -1? Is that what you're asking?
Yeah, -3 and -1.
Well, I know it's
maximum and then
right. I know it's clearly in between there somewhere. Right. Clearly, this maximum is in between here and here. Now I could have chose -2.5, -1.5, but this is clearly
between
between
-3
there and there.
and -1.
Now the min is a little weird because it's kind of flat here. So I chose, it's clearly between here,
And 1.
and I chose 2 because, you know, who knows, just to be safe.
But
You could choose one and it'll work.
Actually, honestly.
But I'm sure that it's between here and here.
I see.
Yeah.
And then you would always put x next to the y1.
Yeah.
Yeah, I know.
So if this way just confused you and you don't like it, you don't have to use it. I'm going to copy this over also.
Right, you have max and F min. That's what we're all doing.
Go to math. And when, I'll let you, can you figure it out from there?
Oh, yeah, I can. But
So,
then would I just put that directly
yeah.
into what?
Gotta have confidence.
On the
Just do it.
Like what are you thinking?
All right, wait, first over here.
On the exam, do you want us to write both points or just
Well,
zeros?
if I say the x-intercept, an intercept is a point. But I would probably give you credit if you just put the first number.
Okay.
On my math lab, it would say, you know, underneath it says insert an ordered pair. So it always tells you what it wants.
There's so many times where I have the right answer, but it will tell me
Yeah.
wrong.
So here might be the answer to your question. This is what I put in right here.
Where did you get -3, -1 from? The maximum minimum points?
Because it's the max is clearly between -3 and -1, right? It's in between here somewhere.
Yeah.
Yeah. It's like choosing the left and right bound. Question?
Could you, for example, use -3 and 0?
You can use -3 and 0. You can use -10 to. Now you can't go too far because then it won't work.
Just something that looks like
It's like the
between there.
it's like the left and right bound. You can choose a little bit more this way. You could choose a little bit more this way, or you could get it really really close. But then you have to be sure that it really is in there.
Can you scroll it up a little bit? You just did it.
Yeah, I'm fine.
Now the reason this one was a little bit easier is because the range was because this graph, well, we can see here, this graph is clearly this type of graph. I know that it has to go through 0 at some point because it goes to negative infinity to positive infinity. Somewhere it has to cross. But like parabolas don't ever have to cross, right? They can come down and go up without ever crossing the x-axis. So now let's ask another type of question. And thank you for ask these questions when they arise. That's good. P of x. So this one I'll make a little bit easier or a little bit shorter. The domain, the extrema, and the range. Now notice I changed the order of these questions. I'm saying find the range last. You'll see why when you do this problem. Well, actually, let's analyze this first of all. How is this graph going to look like? Which part of the YMCA is it? Goal! Right? Now, what that means is this function going to go to negative infinity? No. So the range is not necessarily negative infinity to infinity. The domain is always negative infinity to infinity for polynomials. Unless you're dividing by 0 or taking a radical of a negative number, it's just always this. But now I got to find the range. So hint, find the extrema first, then find the range. Remember, the fun is just beginning in this class. So I'm also going to give you a little hint. Just to help you out, graph this on -6, 6 by -80, 50. Yeah. Yeah, because I don't want to spend all our time looking for that right window. See, at least Isabel's thankful. No one else thanked me. That's what I got. I'll take attendance while you guys work on that. All right, so these are the maxes and mins. Now, what is the range? The range is what? Is what?
Negative 42 to infinity, if you round.
Right. Well, yeah. So the range is negative 41.61 to infinity. That's as low as it gets. This right here, from here, that way is the range. And this number is negative 41.61. So any number below that, why doesn't it approach it? Why doesn't ever achieve it?
So, okay.
Because the behavior is like this, because the behavior is go up on both sides, then it can't go to negative infinity. It doesn't have the chance to. Question.
I was wondering how you got the second part. Like, I only got negative 3.1.
Yeah.
The second one? So you have to do it again using, it'll only give you one answer. So you did the first one, now you got to redo it again with this one.
And then the bottom one, yeah, 2.31.
2.31 and then negative 18.63. Where does this come from? When you do the min on this one, you'll get it. So I'll do that one. So you have to do it again. Doing it once, doing it the first time over here will not give you the one over here. So I have to redo it again.
By looking
Oops.
at the points for the minimum, from there you can find the range.
Yeah. Because that's the smallest it gets. So that's the range. Now what did I do? I broke it. I wanted to find the min, right? So the min, I have to go over here now. Now I could just choose right here, right? There's no reason why. I'm gonna make it, you know, way over here. Now I have to be sure I have the min included. So that means I have to start going up. So I can use these numbers to tell me if I'm going up. Now clearly it's between here and here. Would you agree? And I just press enter. And there's my numbers. But yeah, that's why you do the balance, because there could be multiple answers. There could be multiple zeros here. This screen's about to blow up, huh?
Can you go back to your minimum, to your extremity?
Yeah.
Yes.
What?
Do we have to round up?
Well, unless you want to write all infinite numbers. So usually the problem will say do 2 decimal places, 3 decimal places. But these are irrational. Well, yeah, they're irrational, I would guess. So so I'll make you guys a deal.